Hello everyone, welcome to Sangam Tutorials, Gubbi online classes for Ncert and Cbse 10th standard classes for mathematics and science. So in the previous session we had proved a theorem based on areas of similar triangles, so which was very important for your examination for 4 marks. So in this session we will be going with numericals including riders on areas of similar triangles. Very simple problems, very conceptually oriented problems. You have to listen very carefully and practice it, right? Okay, we'll go with the first problem here. So it will be for 2 marks. So it's a numerical problem here. So a triangle ABC is similar to triangle DEF. So one thing we have to remember before entering into the problems: areas of similar triangles are proportional to the squares on their corresponding sides. See, if you want to compare the areas of two similar triangles and their corresponding side, that is squares on their corresponding sides, then both the triangles should be compulsory similar to each other. Then only we can apply this theorem. If they are not similar, we have to show that they are similar and then we have to apply the theorem, right? So here in the data, he has already given, that is triangle ABC is similar to triangle DEF. It's already given, so no problem. So we can just for our reference, we can draw 2 triangles here. So one is triangle ABC, another is triangle DEF. Okay, let us go with a little bigger one. So this is triangle DEF. So these are the 2 triangles, and their areas are respectively 64 square centimeters and 121 square centimeters. So its area, the space inside this, its area is 64 and its area is 121 square centimeters. Okay, so both the triangles are already similar to each other, right? So if EF is equal to 15.4, EF, the length of EF is 15.4 centimeters, then find BC. You have to find this, because for EF in triangle DEF, BC will be the corresponding side in triangle ABC. So in the theorem we have observed that area of triangle ABC by area of triangle DEF is equal to AB square by DF square something. So there are 4 elements. Area of triangle ABC is the one element, area of triangle DEF here second element, BC one element, and DF another element. So therefore there are 4 elements. So out of these 4 elements he has given 3 elements and he has asked you to find out the remaining element. Okay. So as both the triangles are already similar, so I will start with the similarity. So triangle ABC is similar to triangle DEF. So therefore area of, or you can write it like this, simple, area of triangle ABC by area of triangle DEF is equal to, we will take the squares on their corresponding sides. So as we have taken the name of triangle ABC first, so therefore we will write BC square by EF square. So you have to write a reason here. So reason is areas of similar triangles are proportional to squares on corresponding sides. So this is the reason you have to write whenever you write this theorem, that is when you represent the theorem. So now area of triangle ABC value is 64 by area of triangle DEF value is 121 is equal to BC square. BC we have to find it out, so therefore BC square remains. So EF square, EF is 15.4, we have to write EF square, so therefore it becomes 15.4 whole square. Okay. Let us take square root on both sides, because we have 64 as a perfect square, 121 as a perfect square here. So we can take square root on both sides. Square root of 64 by 121 is equal to square root of, we can take this BC by 15.4 like this, BC by 15.4 whole square. We can give the whole square for this because the numerator is a perfect square, denominator is a perfect square. So therefore we can give a whole square to that according to the law of indices. So square root of 64 is 8 by square root of 121 is 11 is equal to square and root cancels. So this becomes BC by 15.4. So 11 into BC, so on cross multiplication, 11 into BC is 8 into 15.4. So BC is equal to 8 into 15.4 divided by 11. So BC is equal to 11 1 times 11 ones are 11, 4.4, so it is 0.4. So 11 fours are, it is 44. So 8 into 1.4. So BC is equal to 8 fours are 32. 8 ones are 8, 9, 10, 11. So that is 11.2 centimeters. So what is the length of BC? The length of BC is 11.2 centimeters. So this will be asked for 2 marks in your examination. Right. We go with the next problem. Diagonal of trapezium ABCD, diagonal of trapezium ABCD, where AB is parallel to CD, intersect each other at O. Okay. If AB is equal to 2CD, is the condition. If AB is equal to 2CD, find the ratio of areas of triangle AOB and triangle COD. Okay, so this is the diagram, very important. Okay, so diagonal of trapezium ABCD, where AB is parallel to CD, right? AB is parallel to CD, intersect each other at O. So AC is one of the diagonal, BD is another diagonal, so they intersect at point O, right? So if AB is equal to 2CD, so length of AB is twice that of CD. So if CD is 2 centimeters, then AB will be 4. If CD is 10 centimeter, AB will be 20, something like that. So find the ratio of the areas of triangle AOB. So this is that is triangle AOB, you can identify here, and this is triangle COD, you can identify here. So you have to find the ratio between the areas of two triangles, that is AOB and triangle COD. Okay, so let us get into the data. So ABCD is a trapezium. ABCD is a trapezium. So AB is parallel to CD and AB is equal to 2CD. Alright, so this is enough. So to find, so you have to find area of triangle AOB by area of triangle COD. That is ratio between area of triangle AOB and area of triangle COD we have to find out. Okay, so we'll go with the proof. So here it has been asked to find out the ratio of areas of triangle AOB and triangle COD, but we do not know whether triangle AOB and triangle COD are similar or not, because in order to apply the theorem, first the triangle should be compulsory similar. So similarity between AOB and COD is not given here, so therefore we have to select both the triangles and then we have to show that they are similar and then we have to apply the theorem. So this is very important. So in triangle AOB and triangle COD, alright. Now as AB is parallel to CD, angle BAO, that is this angle, will be equal to angle OCD. So they are alternate angles. So angle BAO is equal to angle OCD because these two are parallel lines. If you consider this and if you consider this as the transversal, so then this becomes alternate angles. So angle BAO is equal to angle OCD. So angle BAO is equal to angle OCD. Reason is alternate angles. You have to write the full form, and then angle AOB, this angle is equal to angle COD, that is this angle, because they are vertically opposite angles. So here AC and BD are the two straight lines which intersect at point O. So two diagonals can be considered as two straight lines. So angle AOB is equal to angle COD. Angle AOB is equal to angle COD. So that is vertically opposite angles. You have to write the full form here. So therefore triangle AOB and triangle COD are equiangular. They have become equiangular because in these two triangles, two pairs of corresponding angles have become equal. So therefore they are equiangular. So if two triangles are equiangular, then they will be similar. That is, triangle AOB is similar to triangle COD. So this is according to AA criterion. So both the triangles are similar. So now we can apply the theorem, area's theorem. So therefore area of triangle AOB by area of triangle COD is equal to, we will consider the corresponding sides. So in triangle AOB we will take AB, and in triangle COD we will take CD, because these two are the corresponding angles. Opposite to that is AB, opposite to this is CD. So therefore AB square by CD square. AB square by CD square. So according to the theorem, area's theorem, right? So now we have to find the areas here, that is ratio between areas. So area of triangle AOB by area of triangle COD is equal to AB is there here. So we know that AB is twice CD. So instead of AB we will substitute twice CD whole square by CD square, right? So area of triangle AOB by area of triangle COD is equal to 2CD whole square becomes 4CD square by CD square remains. CD square remains. So CD square and CD square gets cancelled. So area of triangle AOB by area of triangle COD is equal to 4 by 1, which is equal to 4:1. So this is the ratio between the two triangles. That is, area of triangle AOB and area of triangle COD are in the ratio 4:1. Right. So this will be asked for 2 marks again in your examination. Right. We'll go with the next problem. So in the figure, ABC and DBC are two triangles on same base BC same base BC. If AD intersects BC at O, show that area of triangle ABC by area of triangle DBC is equal to OA by OD. So it's a identity, very important. So it is, let us get into the diagram. Right. So you can observe here. So in the figure, ABC and DBC are two triangles. So you can see here, ABC is one of the triangle and DBC is another triangle. So both the triangles are on the same base BC. They are on the same base BC. If AD intersects BC at O, so AD is another diagonal which is intersecting BC at point O here. So you have to show that area of triangle ABC, that is area of triangle ABC by area of triangle DBC, that is DBC is equal to OA by OD, that is the ratio of area of triangle ABC and ratio of triangle area of triangle DBC. The ratio between these two triangles areas is equal to the ratio between OA and OD. So that is we have to show here. So we'll get into data. So triangle ABC and triangle DBC are on same base BC. So this is the very important thing. So to show that area of triangle ABC by area of triangle DBC is equal to OA by OD. Right. So we need a little bit of construction because to prove this data is not sufficient. So let us go with the small construction. Alright. So now draw AM perpendicular to BC and draw DN perpendicular to BC. So for the same BC, draw AM perpendicular to BC and DN perpendicular to BC. So draw AM perpendicular to BC, DN perpendicular to BC. Right. So this is the construction part. So let us get into the proof. Now we will select these two triangles, that is triangle AOM and triangle DON. Right. So in triangle AOM and triangle DON. Okay. Now angle AMO is equal to angle DNO, that is 90 degrees, both are 90 degrees. So angle AMO is equal to angle DNO. Angle AMO is equal to angle DNO. So reason is by construction we have got it. So that is 90 degree each. And then angle AOM, that is this angle, is equal to angle DNO, that is DON, this angle. So they are vertically opposite angles. So angle AOM is equal to angle DON. Angle AOM is equal to angle DON. So they are vertically opposite angles. So therefore in both the triangles two pairs of corresponding angles have become equal. So therefore triangle AOM and triangle DON are equiangular. They are equiangular. So therefore triangle AOM is similar to triangle DON. So according to AA criterion, both the triangles have become similar, right? So if two triangles are similar, we can apply the areas theorem. So area of triangle AOM by, or we can take the proportionality AM by DN. Okay, let us take the proportionality is enough. So AM by DN is equal to AM by DN is equal to OA by OD, because opposite to 90 is OA, opposite to 90 here is OD. So we can take OA by OD, and opposite to the vertically opposite angles, this one is AM and for this one is DN. So AM by DN. So we can take it. Okay, so take it as equation 1 and let us wait to use this result in the next steps. Now, let us take the area of triangle ABC and area of triangle BCD. Area of triangle ABC by area of triangle BCD is equal to half into, what is area of triangle ABC? We will define that half into base into height. So for triangle ABC, BC is the base and AM becomes the height. So it is area of triangle ABC is equal to half into BC into AM. Half into BC into AM by, for triangle BCD we will take it. So for triangle BCD, BC is again the base and DN becomes the altitude. So therefore half into BC into DN. So half into BC into DN. So half and half cancels, BC and BC cancels. So area of triangle ABC by area of triangle BCD is equal to AM by DN. We have got here as equation 2, right? So now, but here AM by DN is equal to OA by OD. So instead of AM by DN here, we can write OA by OD. So therefore, from, okay, we can write it like this, but AM by DN is equal to OA by OD, that is from equation 1. So therefore, area of triangle ABC by area of triangle BCD is equal to, instead of AM by DN, I am going to write OA by OD. So hence it is good. So this will be asked for 3 marks in your examination. It's a very important problem. You have to practice this. It's very, very important. So now we'll go with the 4th problem, which is very important, which has been asked in the previous exams for 2 marks, 3 marks and all. So if the areas of 2 similar triangles are equal, the areas of 2 similar triangles are equal, then prove that they are congruent. Then prove that they are congruent. So this is very important. It was asked for 1 mark. The statement itself was asked for 1 mark. The entire problem was rider was asked. That is rider. It's a rider. So it was asked for 3 marks. So if the areas of 2 similar triangles are equal, so 2 similar triangles are there, their areas have become equal. So if they are equal, then prove that they are congruent. So while discussing the basic concept of similarity in the previous sessions, I had told you this. So if 2 triangles have equal areas, then they are congruent. So congruent triangles are always similar. So the reverse of this, they are asking you. So if the areas of 2 similar triangles are equal, then prove that they are congruent. So let us get into a diagram. Very important. So let us take 2 similar triangles. Take it as triangle ABC. Let us take this as triangle PQR. So here both the triangles areas are equal. So this area of triangle ABC is equal to area of triangle PQR, and also they are similar. If the areas of 2 similar triangles are equal, so they are similar, already they are similar, and also their areas are also equal. So if this is the thing, prove that they are congruent. We have to prove the triangles as congruent. So in order to prove any 2 triangles to be congruent, we use any one of the 4 postulates we had learnt in the previous classes, that is in your 8th standard class. So let us get into data. So triangle ABC is similar to triangle PQR, and area of triangle ABC is equal to area of triangle PQR, right? So this is the given thing. So you have to prove that triangle ABC is congruent to triangle PQR, right? So let us get into the proof. Very important. Right, we will take up this concept and move on. So triangle ABC is similar to triangle PQR. So it is given, right? So if 2 triangles are similar, then the squares on their corresponding sides will be proportional. That is, the areas of similar triangles will be proportional to the squares on their corresponding sides. So therefore, area of triangle ABC by area of triangle PQR is equal to BC square by QR square, BC square by QR square, which is also equal to AB square by PQ square, AB square by PQ square, which is also equal to AC square by PR square. AC square by PR square. So now, as area of triangle ABC is equal to area of triangle PQR, so area of triangle ABC is equal to area of triangle PQR, they get cancelled and they will be equal to 1. So is equal to, for example, if area of triangle ABC is 100 square centimeters, then area of triangle PQR will also be 100 square centimeters. So 100 by 100 gets cancelled, so it is equal to 1. So 1 is equal to BC square by QR square, which is equal to AB square by PQ square, which is equal to AC square by PR square, right? So let us equate every term with 1. So therefore BC square by QR square is equal to 1. So if a fraction is equal to 1, then the numerator will be equal to the denominator. So therefore BC square is equal to QR square. So if you take square root on both sides, they gets cancelled. So BC is equal to QR. So this is one of the result we have got. So then we had equated this to this. Again we will equate this with 1. So AB square by PQ square is equal to 1. So therefore AB square will be equal to PQ square. So therefore AB is equal to PQ. So this is another result we have got. So then we will equate this with 1. So AC square by PR square is equal to 1. So therefore AC square is equal to PR square. So therefore AC is equal to PR. So these are the three results we have got. So now we will select both the triangles there. So in triangle ABC and triangle PQR, BC is equal to QR, BC is equal to QR, then AB is equal to PQ, and then AC is equal to PR. So let us look at the figure here. So AB is equal, BC is equal to QR, AB is equal to PQ, and AC is equal to PR. So all the three are proved. Right. So therefore triangle ABC is congruent to triangle PQR according to SSS postulate. SSS postulate. So if three sides of one triangle are correspondingly equal to the three sides of the other triangle, then both the triangles should be congruent to each other. So this is how we have to prove this. So this was asked for 3 marks in one of the examination and for 2 marks in one of the examination. So it's a very important problem, right? So all the 4 problems what we have done today are very important. Please practice the problems. Still more problems on the areas of similar triangles I am going to present in the tomorrow's session. Until then, stay safe, stay home and keep learning. Thank you.